Every enterprise has a coal face. It's the point where clean, structured corporate systems collide with the chaotic reality of the physical world. This is where work touches reality, processing edge case invoices, resolving customer claims, and rerouting logistics through unpredictable environments. Because routine execution is highly observable and repetitive, the coalface is the most obvious target for AI automation. Traditionally, human bottlenecks cause data queues. Agents eliminate delay, but their speed lets subtle edge case errors slip past undetected. AI blindly follows standard workflows, missing anomalies humans naturally catch. This disconnect disskills the front line into passive observers. Without field connection, enterprise learning stops. Maintaining a legacy execution model while adding AI speed only widens this gap between the firm's actions and its understanding of the market. Reversing this intelligence drift requires an architecture built specifically for a new role, the agentic operator. Industry orthodoxy suggests that keeping a human in the loop is the only way to ensure AI safety. Mathematically, this creates a scaling failure. Forcing every automated task through a manual approval path forces a linear human to bottleneck an exponential technology. However, removing the human entirely triggers governance and compliance failures that no regulated enterprise can survive. The solution is to move the human above the loop. In this model, agents execute routine work end-to-end autonomously. The operator's role shifts from moving the work to validating the outcomes. The connection between the human and the agent is maintained through a control mechanism called the permission envelope. This envelope sets the specific bounds of the agent's authority, establishing exactly what it can execute without a manual check. By positioning humans above the loop, the firm decouples its headcount from its routine throughput, solving the scaling paradox. High-velocity autonomy requires a way to prevent agents from making high-stakes, uncorrectable mistakes. This is managed through a bimodal governance architecture, which splits every agent decision into two pathways based on reversibility. The first pathway is the two-way door. This is for reversible actions, where the cost of a mistake is low. Here, the system optimizes for velocity. Data flows continuously, and if an error is detected, the agent simply pulls back and tries a different route. The second pathway is the one-way door, reserved for irreversible or high-risk decisions. When an agent encounters a one-way door, the workflow stops. The agent lacks the authority to proceed on its own. Unlocking this gate requires a synchronous signal from the human operator, ensuring high-stakes actions always have explicit oversight. This strategy maximizes execution speed for routine work while capping the firm's exposure to irreversible risks. Scaling these relationships across an entire enterprise requires a shift in how the organization itself is structured. Rigid departmental silos move too slowly to keep pace with agentic execution. The cross-functional pod becomes the primary unit of execution. These pods, consisting of 3 to 8 humans and their agent clusters, form dynamically around problems and share direct access to enterprise data. While execution must be fluid, legal liability and fiduciary duties cannot be decentralized. To manage this, the firm maintains a residual accountability hierarchy behind the agile pods. This compressed hierarchy, often only 2 or 3 layers deep, handles performance evaluation, career continuity, and regulatory sign-offs. We call this tension between agile execution and static liability the fiduciary wedge. Winning firms don't eliminate hierarchy, they compress it, making it invisible during daily work while keeping it structurally sound for compliance. No system is perfect. The architecture must account for the messy, undocumented realities of the physical world. Imagine an unpredictable vibration in a piece of industrial machinery. It's an edge case that doesn't exist in the AI's training data. In legacy firms, the knowledge of how to fix this dies in slow-moving escalation tickets and manual reports. In an AI-native model, the agentic operator intervenes the moment the agent's logic reaches its limit. This intervention fuels the frontline learning loop, the enterprise's primary mechanism for reality correction. The operator's value is now found in annotating these edge cases and structurally improving the AI's playbooks. Every manual override is captured as direct training data for the central intelligence stack. The frontline functions as a sensory organ for the enterprise, providing the continuous reality correction that keeps the intelligence stack from drifting. Architecture alone isn't enough. To make these principles work, the firm must change its daily operational rhythm. Implementing the learning loop requires a complete overhaul of how time is spent within the organization. The most accurate indicator of a real transformation is the CEO's calendar. The legacy corporate schedule, filled with passive reporting and status updates, disappears. It is replaced by pod stand-ups, where agents pre-summarize blockers and signals so humans can focus purely on exceptions. Weekly meetings shift to exception reviews, dedicated entirely to updating agent specifications based on the week's edge cases. When this architecture is correctly deployed, the organizational tree shatters and rebuilds into a massive cluster. We shift from a traditional 1-to-6 manager to employee ratio to 1-to-20 or higher. This oversight is only possible because agents have absorbed the burden of routine throughput. Leaders must audit these ratios to determine if their redesign has actually reached the coalface. If your ratios haven't moved toward 1-to-20, you haven't achieved a structural transformation. You've simply bought a faster typewriter.